Most of us only ever notice a mosquito in the exact moment it lands on our skin. We treat them as flying annoyances, completely ignoring the complex, multi-stage biological machinery that makes them such effective parasites. To understand how they actually operate, we're starting with a controlled colony of 1,000 dormant mosquito eggs. Right now, they look like microscopic specks of dust. But the second these dry eggs touch water, a rapid biological trigger activates. The embryos absorb the moisture, and within minutes, the casing splits open to release a tiny, living larva. At this stage, these newly hatched wigglers are virtually microscopic and completely defenseless. Yet, in just a matter of days, they are destined to become highly specialized predators. Which raises a biological mystery. How does an organism completely rewrite its own internal instincts to transition from a vulnerable, water-bound prey animal into an airborne hunter? The transformation starts with an aggressive growth cycle. These aquatic larvae consume so much fuel that they double their physical size every 24 hours. They sustain this growth using microscopic, motor-like mouths that constantly churn, filtering suspended organic matter right out of the water. Their behavior at this stage reveals a lot about their hardwiring. We know adult mosquitoes are relentlessly attracted to light. They will eagerly swarm a bulb at night. This diagram of a larval tank shows the exact opposite behavior. When a bright directional light hits the water, the larvae actively reject the adult instinct, instantly fleeing to the far side of the tank to stay in the shadows. They cluster in the darkness because their instinct at this life stage is purely defensive, avoiding the gaze of aquatic predators like fish. During this first phase of life, the mosquito operates entirely as a bottom-feeding prey animal, governed strictly by fear and avoidance. That massive rate of growth has a physical cost. To accommodate their expanding bodies, the larvae must violently shed their outer skin 4 separate times. The mechanics of this molt are highly specific. The insect has to hang completely upside down from the water's surface, using gravity to slowly slide out of its old casing. It's an agonizing process that burns massive amounts of energy. For many larvae, the effort is fatal, acting as a brutal biological filter that only allows the strongest insects to survive. In this graphic, you can see the result of that final molt. The larvae becomes a pupa, or a tumbler, developing complex eyes and relying on these small horns that act as snorkels to draw oxygen from the surface. As days pass, this pupal casing gradually turns dark black. That color shift is the final biological countdown before emergence. This precarious pupal stage bridges 2 completely different environments. It is the brief window where the insect's initial sensory suite is erased and rewritten for the air. When it's time to hatch, the pupa straightens its tail to create leverage. The casing along the thorax splits open, and the adult mosquito slowly pulls its delicate folded wings and legs out into the open air. There is a mandatory waiting period before it can fly. The insect must stand completely still on the water's surface for up to half an hour, waiting for its soft exoskeleton and wings to harden. The moment it finally takes flight, the biological flip is complete. The light-fleeing, bottom-feeding aquatic prey is replaced entirely by a light-swarming, airborne predator. With a new adult colony active, we can test exactly how this new sensory array operates. First, we tried high-frequency sound apps that claimed to deter bites. The mosquitoes ignored the noise completely and landed right on the target. This diagram illustrates why chemical repellents work. Mosquitoes track targets using sensitive antennae, picking up heat and scent waves radiating from skin. When a chemical spray is applied, particles bind to these receptors. The spray physically blocks the pathways, effectively hiding the target. Adult mosquitoes rely entirely on these heat and scent receptors, operating effectively as biological heat-seeking whistles. To see exactly how rigid these hunting instincts are, we presented the starved colony with an ultimate test, a pool of real, warmed cow blood covered by a thin membrane to simulate skin. The result was totally counterintuitive. Over a 2-day period, not a single mosquito out of the 100 in the tank attempted to feed from it. They completely ignored a free meal because of a biological blind spot. Adult mosquitoes require the full, holistic sensory experience of a live hunt. Without the carbon dioxide trails of a breathing animal and the specific mechanics of landing on live tissue, their feeding instinct simply will not trigger. Because they refuse to eat, and letting an experimental colony escape into the wild is illegal, the entire swarm ultimately had to be safely terminated in a deep freezer. A mosquito cannot be tricked by a simple jar of warm blood. It is a highly complex, two-stage hunting machine, governed by millions of years of unbreakable evolution.